Hello everyone. So now we are going to start the topic number 1.6, which is the system properties, and we are going to look at different system properties and what does those properties actually imply. Now, each of the property is going to have some physical interpretation regarding the system on which we are going to test. So we will see each property now. So the first one, before I jump into the properties, let me just quickly write something which we have discussed in the previous lecture. So we discussed that a system, whenever it comes to a system, we are going to assume that our x of t or x of n is going to be the input. So we're going to use this variable to represent the input, and then it's going to pass through some system, and depending upon the system, we are going to get some output. And in case of a continuous time system, the input is going to be x of t, and the output is also going to be y of t, which is continuous. And in case of a discrete time system, if you give an input x of n, then the output is also going to be the discrete time output, and we're going to represent it with y of n. So now let's see the first property, which is the system with memory or without memory. What do we mean? Okay, so here is a formal definition. A system is said to be a memoryless if its output for each value of the independent variable at a given time is dependent only on the input at the same time now. So output, first of all, we have mentioned the output over here. So remember, for the output, we are going to use the variable y of t or y of n, as I have just told you. And then for the input, we are going to use the variable x of t or x of n. Okay. And both t is basically the time and the n is the number of sample. These are the independent variables. T and n are the independent variables in the continuous time and in discrete time domain. Okay, so to simplify this definition, I could have also said that the a system is considered to have a memory if output of the system depends on the past or the future values of the input. Or the two terms which I'm going to use is basically a system with memory and a system without memory, which we are going to call memoryless system. Okay. Memoryless system. So a system is considered to be a memoryless system if output of the system depends upon the only the present value of the input. So let me write this definition as well. A system is considered to be a memoryless system if output of system depends only on present value of input. Okay, so let's first discuss what do I mean by the present value of the input or output, the past value of the input or the future value of the input. So I'm going to take three simple examples. Let's say we have a system y of t is equal to x of t. Okay, this is one system, and then let's assume there is another system which is y of t, and this is basically, you can identify that this is basically a delay system. And then let's write another example which is x of t plus 1, which is an advanced system. So now, in order to test whether the output depends only on the present value of the input, what we can simply do is, let's substitute the value t is equal to 0. Okay, if I substitute the value t is equal to 0 in this equation, so what I get is y of 0 is equal to x of 0. So the output depends on the input at the same time value. So y0 is equal to x of 0. Similarly, if I substitute another value, let's suppose I substitute t is equal to 1 just to test, then what I'm going to get is y of 1 is equal to x of 1, which means in order to find out the output y at t is equal to 1, I need the value of the input x at the same t is equal to 1. So the output depends on the input at the same value of the time, which is 1 in this case. Similarly, you could have tried t is equal to -1 as well, and you're going to get y minus 1 is equal to x minus 1. So this is what we mean that the output depends upon the same value of the input. Now, if we look at this particular example and we again substitute t is equal to 0, so what we're going to get is y of 0 is going to be now equal to x of -1. So what does that mean now? So depending upon the reference, now the reference was t is equal to 0. So if I simply draw a line over here, just to make things a bit more clearer. So let's say this is the t-axis and this is t is equal to 0. Then -1 value is the past value and +1 is the future value, right? So depending upon your reference, I substituted t is equal to 0, which was this value. So for this value, all these values are considered to be the past values of the time, and the +1, +2 values are going to be considered as the future values of the time. So if I would have chosen -1 as a reference, then the 0 is considered to be the future value and -2, -3 are the past values. Okay. So what we are looking at over here now is that y0 output depends upon the past value of the input. So x minus 1 is the past value of the input. So output is not depending upon the past value of the input. So that is what we mean when we say that past value. Okay. You could have tried the another one. If I substitute t is equal to 1, okay, so t is equal to 1 is going to give me y1, and then this is going to be equal to x of 0. So again, now the reference point is 1, and what we are looking at that for in order to compute y1, we need a value of x0, which is actually the past value now. So 1 over here is a reference, and then 0 in terms of the 1 is now a past value. Okay, so here is a third case scenario. So this is a system which actually requires the past values. All right, this actually demands the past values. This is a system which demands only the present values. And then here is another system, and if we again substitute t is equal to 0 over here, so what we are going to get is y of 0, and now we are going to get x of 1. So now in order to compute the y0, I need a future value of the input. That is 1 now. So in terms of the reference 0, 1 is now a future value. Similarly, if I take another value, t is equal to 1, so I'm going to get y of 1, and over here I'm going to get x of 2. So what I'm simply doing, substituting the values in this equation. So y1, in order to find out the y1, I need the future value of the input. So remember, x is representing input and the y is representing the output, as I have just told you over here, that these are going to be the inputs and these are going to be the outputs. All right. So since we have now understood what do we mean by the past value and the future value and the present value, let's look at the definition of a system with memory or memoryless. Okay. So now a system is going to be considered as a memoryless if output of a system depends only on the present value of the input, okay, which is this case only, right? And for any of the other two cases, if the output depends upon the past value or the future value of the input, we are simply going to say that our system has some memory, okay? So let's take few examples to understand in a bit more detail. So the first example which I want to include is basically the same example which we have already discussed, which is y of t is equal to x of t. So this is basically an identity system. Just in case if you want to give a name to this system, this is an identity system, which means whatever is the input is going to be the output. So the identity system is simply whatever the input is, the output is going to be the same, which is y is equal to x of t. So we have already tested this, and if you want to do it again very quickly, we can try a few values at t is equal to 0, t is equal to -1, and let's take one value, t is equal to +1. It's always recommended to try 3, 4 values. We could have tried -2 and +2 as well, but it's quite evident that y of 0 is going to be equal to x of 0. Similarly, y of -1 is going to be equal to x of -1, and y of plus 1 is going to give me x of plus 1. So the output is depending upon the input at the same time instant. So what we can say is that this particular system is a memoryless system. It doesn't have any memory. Okay, so let me write few systems which are memoryless system now. So another system which we can write is actually a system like this. We can have either the continuous time or discrete time system, it doesn't matter. So there is another system, 2 times x square n. Okay. So now this x square is basically the square of the amplitude. Don't confuse it with the xn square, which is a different system, which I'm going to write in a while. So again, you can try different values of the t, or sorry, the different values of n now. So we can try the value of n is equal to 0. So that is going to give me y of 0. And this is going to be 2x square 0, which means I still need the input value at at n is equal to 0 to find out the value of output at n is equal to 0, which is fine. So you could try another few values, plus 1, plus 2, and it's quite simple to see that this system is again a memoryless system. Okay, so another example which we can write over here is the similar example, which just an extension of this thing. Let me write that now. 2 times x of n minus x square n, and then let's take a square of this thing. Okay, so again by substituting few values you can very quickly see this, that this particular system is again a memoryless system. Okay, so the output n depends on the input at the same value of the n. Okay, so here is another example, which is a bit tricky example. So let me give you that as well. So let's say we have a system y of t is equal to e raised to power minus t plus 1 x of t. So now by looking at the system equation, one might imply that since we have a t plus 1 over here, the system is going to be a memory-based system. But what you need to understand is that this particular term, e raised to power minus t plus 1, is not an input term. The input is basically this thing, x of t. So this is going to be simply a constant. This is a constant term, although it depends upon the t itself, but it is a constant. Okay, so if I start substituting the values, for example, y of 0, this thing is simply e raised to power minus 1, and it has some value, and that is a constant value, and then you have x of 0. Similarly, if I substitute y of 1, if I try to find out y of 1, it's going to be simply e raised to power minus 2, which is again a constant, and x of 1. So the output is dependent upon the input at the same value of the time, 0, 0, 1, and 1. You could try a few other values as well if you want. So again, this is another example of a memoryless system. So far, we have seen the examples of the memoryless systems, right? So all these examples are of memoryless systems. Okay, so now let's turn to examples of few memory-based systems. Okay, let's see few memory-based system examples. Okay, so the first obvious example, which we have already discussed, is like this, which is simply an advanced system, or y of n is equal to x of n minus 1, which we have already discussed. So you can try the different values of n. For example, if I just try the value of n is equal to 0, what I can see is that y of 0 is going to be, in this case, it's going to be equal to x of 1. Whereas for this particular system, y of 0 is going to be equal, for this particular system, y of 0 is going to be equal to x of minus 1. So what we can see is that the output depends upon the input at the future value of the n. It's the future value of the input, right? And similarly in this system, the output to calculate the output, I need the past value of the input. So these both are the examples of a memory-based systems. Okay, let's take another example. Example which is a bit, what we can say, a tricky one. So let's try that one now. So the example is, let's say the system equation is y of t is equal to x sine of t. Okay, so let's try a few values. Let's start with the t is equal to 0. So at t is equal to 0, what I get is y of 0 x sine of 0. And we know that sine 0 is equal to 0. Okay, so at t is equal to 0, we can see that y0 is equal to x0. But you need to try 3 to 4 different values in order to get an answer. So let's try another value. Let's try t is equal to pi. Okay, let's take t is equal to pi. So now y of pi is equal to x sine of pi. And the pi is actually 3.14 something. And now x of sine pi is now 0. So now from here, this particular equation, what you can see is that in order to find out the output at t is equal to 3.14, I need the value of input at t is equal to 0. So the system requires an input, the past value of the input. So now, because of that, system has some memory. It is a memory-based system. Okay, so another example is, let's say we have a system which is represented like this, x of 2 times t, right? So now again, you can try some values. So if I try y of 0, I do get the value of x of 0, but you need to try a few more values. So if I take y of minus 1, it's going to give me x of minus 2, right? And if I take y of 1, it's going to give me a value of x of plus 2, right? So what we can see over here is that y minus 1, I need a past value. This is now a past value example of the input. And in order to compute y1, I need the future value of the input. So this system basically requires both the past and present value depending upon the value of the t. So it's quite evident because of these two expressions that the output basically requires either the past or the future value of the input, and due to this particular reason, this is another example of a memory based system. So now concluding remarks are, if you have any system which involves either an integral, or it involves a summation, or a differential, okay, a differential, or it's a delay system, which means it has a terms like this, t minus 1 terms, or it has a term like t plus 1 terms, which are the delay and advance systems. So all these systems are basically memory based systems. Okay, so one of the example of a memory based system is actually a capacitor system, if we treat it as a system. So the capacitor, uh, what we can see is the voltage is V of t can be written as 1 upon C minus infinity to t current I of t dt. So in order to find out the output, which is a V of t, I need the past values of the current from minus infinity to t, and then I can compute the output. So this is an example of a memory-based system. Another system, which is a memory-based system, and this is the last example, is an accumulator system. So let me write the expression of an accumulator system. So accumulator system has a mathematical expression of this thing. So what the accumulator system does is that it's going to add all the past values of the input to the point where we are trying to find out the output. So I could have written this like this, y of n. If we break this limit, and instead of n, we take it up to n minus 1, and then this is x of k plus x of n. So what I've done is from limit minus infinity to n, I have taken the limit up to n minus 1, and x of n is the remaining term which is written over here. And now this thing, if you compare it with this expression, is simply y of n minus 1. Okay, so now again what you can see is that if I substitute the values in this one, it requires past value of the output now. So again, this is an example of a system which has a memory. So I hope things would have been very clear now with these examples. So in finally, the last thing is that all those systems who have memory are also called dynamic systems. We call those systems dynamic systems, and all the systems which do not have any memory, which are memoryless systems, are also called static systems. So the last thing is, what is the physical interpretation? If you say that my system is a memory-based system, what does that mean? Or if we say that the system is a memoryless system, what does that mean? Whenever you're going to say that my system has a memory, that means that that particular system has some storage mechanism. For example, if we are talking about continuous time system, so that means the system has some mechanism storing the energy. Or if we are talking about the discrete time system and we are saying that my discrete time system is a memory based system, so that means that system has some register elements where the past or the future values can be stored. So this is the first property which we have discussed, a system with memory and memoryless systems and their physical realizations. So I hope this would be clear. And if you have understood this thing, then there are other properties which are very much simple to understand based upon the same description which I have given you over here. So the only thing which you need to clearly understand or check is whether the input and output needs the same value of the time. If the output is dependent upon the input at only the same value of the time, that is the only thing which you need to check to determine whether it's a memory or memoryless system. So thank you and see you in the next video. Bye bye.